We are continuing with the chapter Electrochemistry. Welcome to Chemistry Clinic. So we in the previous lectures we had discussed many topics, and I think probably this will be the last topic. Now this topic is called electrolysis. Okay. What do you understand by term electrolysis? Electrolysis is a process where we pass the electric current through a solution of electrolyte. Okay, in the previous portion, in the cell portion, we were having a system that was called cell, and current was being produced by that cell, okay, by dipping the metal rod in the salt solution. In this portion, or in this phenomenon, we will pass the electric current through the solution of electrolyte. What happens when the current is passed through the solution of electrolyte? Actually, if you kindly see this, suppose this is the solution of sodium chloride, this is the aqueous solution of sodium chloride. Okay, instead of aqueous, I suggest we are taking molten NaCl, molten sodium chloride. Okay, molten sodium chloride means sodium chloride, when the sodium chloride is melted, we will pass the current then. This is the molten sodium chloride, and we put some electrode in it, positive one, and that's the negative one. Okay. Unlike electrochemical cell, here the negative one is called cathode and positive one is called anode. Okay. Basically, molten sodium chloride solution will have two kinds of ion. First, sodium positive ion, and secondly, chloride negative ion. So, as the current will be passed, sodium ion will begin to move toward negatively charged electrode, it means toward cathode, while chloride ion will begin to move toward positively charged electrode, towards anode. And they will get separated from each other. Sodium will deposit on cathode and chloride ion will deposit at anode. As we know that sodium is moving toward the cathode, so we will write here at cathode, and chloride is moving toward the anode, so we will write at anode. Okay. Sodium ion will move toward the cathode. Cathode is having negative charge, it is electronically rich, it is having more electrons. Sodium ion will accept the electron over here and will deposit at sodium solid, while chloride ion will lose their electrons and form chloride radical, free radical plus one electron. Okay. So this phenomenon happens when we pass the electric current through a solution, and the phenomenon is called electrolysis. Electrolysis is a process of passing the electric current through the solution of electrolyte or any solution. The process is called electrolysis. But for any solution we cannot say that electrolysis is going on, because electro means electric, lysis means to break. If the electric current is breaking something, is breaking into ions or separating the ions, then the process is called electrolysis. Electrolysis works on the Faraday's law, and there are two laws of Faraday that we are going to discuss right now. Suppose that if we keep on passing the current in this solution, okay, so what will happen on the cathode? Means here on the cathode, sodium ion will continue to deposit. Sodium ion will continue to deposit. After a certain time, there will be a mass of sodium on this cathode. Okay, so we can say that the mass or the weight of sodium which will deposit over the cathode is called W. Okay, and why this is being deposited over here? Because we are passing the current and it is having the negative charge. That's why it is depositing on this cathode. So in this case, if we talk about, we can say that the mass of substance deposited is directly proportional to the amount of current passed through it. Okay. अगर हम इसमें ज्यादा देर तक करंट पास करते रहेंगे तो हमें ज्यादा मास डिपॉजिट हो जाएगा. हम सोडियम क्लोराइड की जगह इस एक्वस सॉल्यूशन भी ले सकते हैं, सिल्वर नाइट्रेट का एक्वस सॉल्यूशन ले सकते हैं, कॉपर सल्फेट का ले सकते हैं, किसी का भी ले सकते हैं. ठीक है, तो यहां पर किसी भी इलेक्ट्रोड पर डिपॉजिट होने वाली स्पीशीज का मास यानी कि W करंट के अमाउंट ऑफ करंट के डायरेक्टली प्रोपोर्शनल होता है. W इज द मास ऑफ सब्सटेंस डिपॉजिट, mass of substance deposited okay, W is mass of substance deposited, and Q is the amount of current passed the amount of current passed is taken in Coulomb C, and W is the gram, unit of W here the gram. Okay, and how can we calculate the amount of current passed? We have another formula that Q is equals to I into T, where I is the current in ampere, okay, and T is time in second. Time in second. Okay, so the formula we will get over here, it will be W is equals to W is directly proportional to I into T, and if we remove this proportionality sign, we will get another constant over here, that is W is equal to Z into IT. W is equal to Z into IT. Okay, what is that? Z is called equivalent constant. Z is called equivalent constant. Equivalent constant. And I told you I is the current in ampere, T is time in second, I into T is equal to Q. Okay. So we can say that the mass of substance deposited on any electrode is directly proportional to the amount of current passed through it. That is called Faraday's first law, and the formula is here, that is W is equal to ZIT. Now we'll see what is Z. As I discussed that we have W is equals to Z into IT. Okay, and I told you about Z, that Z is called equivalent constant. It is also known as electrochemical equivalent. Electrochemical equivalent. Okay, electrochemical equivalent. Suppose we are passing 1 ampere current, it means I is equal to 1 ampere, and T is 1 second. If we are passing 1 ampere current for 1 second through an electrode, in this case W will be equal to Z W will be equal to Z. Okay, so we can say that the electrochemical equivalent is equal to the weight of or the mass of substance liberated or deposited on any electrode when 1 ampere current is passed for 1 second. It means Z is equal to, or electrochemical equivalent is equal to the mass of substance deposited on electrode on passing 1 ampere current for 1 second. यानी अगर हम 1 एम्पियर करंट 1 सेकंड तक पास करेंगे तो जितना मास किसी भी इलेक्ट्रोड पर डिपॉजिट होगा उसको हम बोलेंगे उस सब्सटेंस का इलेक्ट्रोकेमिकल इक्विवेलेंट. नाउ विल सी Faraday's second law. This was the first law of the Faraday's first law. What was the Faraday's first law? We had this, that mass of substance deposited on electrode is directly proportional to the amount of current passed through it. Now we'll see Faraday's second law. Faraday's second law states about Faraday's second law. Suppose we have more than one electrode and we are passing the same amount of current through the electrodes of different solution. On passing the same amount of the current from different solutions, the amount or the mass deposited on electrodes is directly proportional to the equivalent weight of substance. So if the W1 mass deposited, then it will be directly proportional to the E1. Okay, and we have another electrode in which the W2 mass is deposited, that will be proportionally equal to E2. So we can have W1 upon W2 is equals to E1 upon E2. Okay, and this condition is applicable when the same amount of current is passed through different electrodes. So I am writing over here, when same amount of current is passed through electrodes. Okay, if suppose that the same current that we are passing, that is 1 ampere for 1 second, in this case W1 will be equal to Z1, okay, and W2 equal to Z2. So another formula we can get over here is Z1 upon Z2 is equal to E1 upon E2 when यहाँ पर हमने देखा that W1 is equal to Z1 and W2 is equal to Z2, क्योंकि दोनों ही केसेस में अगर देखेंगे, if we talk about this formula, we have this W is equal to ZIT. For the W1 we have Z1 into IT and W2 is equal to what? Z2. W1 is equal to Z1 into IT and W2 is equal to Z2 into IT. When the ITs are same, but in this case W1 is equal to Z1 and W2 is equal to Z2. So this can have the relation with equivalent weight, that is E1 and E2, and we will get another relation over here, that is what? E is directly proportional to Z. E is directly proportional to Z, and we can write that E is equals to F into Z. Now F is what? F is called Faraday constant. F is called Faraday constant. And 1 Faraday is equals to 96,500 Coulomb. 1 Faraday is the charge of 1 mole of electron, and that is equal to 96,500 coulomb, and we can also write 1 Faraday is equals to 1.6, that is the charge of one electron, 10 raised to the power minus 19 coulomb multiplied by 6.022 into 10 raised to the power 23. Okay, so this is the charge of one mole electron is equal to 1 Faraday. We got another relation over there, that E is equal to F into Z. अगर हम किसी इलेक्ट्रोड से 1 फैराडे करंट पास कर दें तो क्या हो जाएगा? तो हो जाएगा ये that E is equal to Z. कब? When the current is passed through the electrode is 1 Faraday और 96,500 कूलॉम. तो किसी भी इलेक्ट्रोड से अगर हम 96,500 कूलॉम पास कर दें या 1 मोल ऑफ इलेक्ट्रॉन पास कर दें, इतना चार्ज पास कर दें, तो जो सब्सटेंस का इक्विवेलेंट वेट होगा वो Z के बराबर हो जाएगा. ठीक है, इसका मतलब अगर किसी इलेक्ट्रोड से हम 96,500 कूलॉम पास कर देते हैं तो इन दैट केस सब्सटेंस के इक्विवेलेंट वेट के बराबर मास इलेक्ट्रोड पर डिपॉजिट हो जाएगा. एंड वी विल सॉल्व द न्यूमेरिकल ऑन दिस रिलेशनशिप. बिफोर दैट आई वुड लाइक टू टेल यू समथिंग मच मोर. दैट इज व्हाट, suppose that we have copper dipositive ion. One copper ion requires 2 electrons to reduce or to deposit on electrode like this copper solid. Okay, it requires 2 electrons. One copper ion requires 2 electrons. If we have 1 mole of copper ion, that will require 2 mole of electron. Isn't that? If 1 copper ion requires 2 electron, 1 mole of copper ion will require 2 mole of electron. Because it is having 2 unit positive charge, so it is 1 ion is required 2 electrons. Suppose we would have taken sodium ion instead of copper. Sodium ion will require 1 electron per ion, but copper ion is requiring 2 electrons per ion. So to reduce 1 mole of copper ion, to reduce or deposit 1 mole Cu dipositive ion, we requires 2 mole of electron. Okay. If we talk about how much current we will require, so we can say that 1 mole electron, how much current will be required? 1 mole of electron is equal to 1 Faraday charge, means 96,500 coulomb. So to reduce or to deposit 1 mole of copper ion, we will require 2 Faraday charge. It means 2 into 96,500 coulomb charge. So, okay, so this is all about the Faraday's second law. We can also calculate weight like this, because we have deposited 1 mole of copper ion by passing 2 Faraday. And the weight of 1 mole copper ion is 63.5 gram. This is the weight of 1 mole of copper. 1 mole of copper. So this formula and this technique is also useful to calculate the weight of substance deposited by knowing how much current we are passing by the ampere and times method or by the Faraday method. That's it.